Good morning, this is B. Naresh, working as assistant professor in AC department. And today we are going to discuss definitions and terminology on module 3, that is transistor biasing and stabilization. So in this session, we are going to discuss some of the important parameters, definitions, as well as how to represent parameters related to this transistor and biasing, as well as the stabilization concepts. So coming to the first case, then what is an amplifier? So actually, the amplifier can be used to amplify the signal strength. Means we know that in a transistor concept, we have the two types of the transistors. One is either NPN transistor or a PNP transistor. And based on this, based on the construction of the transistor, we know that it contains the two junctions. One is emitter base junction, another one is a collector base junction. And whenever this emitter base junction is a forward bias and the collector base junction is a reverse bias, then the mode of the transistor is enters into the active region. So in this active region, the transistor is acts as a amplifier. So that is the reason. Here the amplifier is a device. It increases the voltage, means the physical quantity parameters like voltage, current, or a power of the signal. And most of the cases, we are going to use these amplifiers in wireless communications, as well as the broadcasting information for the long distance communication, as well as audio equipment like that. These are some examples where we are going to use amplifiers. The main focus of this amplifier is to increase the signal strength in terms of voltage, current, as well as power. Now, what is voltage gain? Means we need to find out after transmitting the signal from the from the one place to the another place. So we need to find out how much means we need to write how much how much input signal should be amplified. That should be measured in terms of the gain. So hence, the output voltage is represented as A times of V. And here, this is called as a gain factor. So this gain factor can be used to increase the signal strength from weak signals to some high signal. So hence, from this, the gain factor is defined as, from this representation, it is a ratio of output voltage to the input voltage, or any output parameter to the input parameter. Now again, what is a bypass capacitor? So in a transistor amplifier, so let us consider if it is when you are taking an emitter transistor, either in a common emitter configuration, and input is biasing through a resistance. Let us take this as RB, and output side, and it is a biased with collector resistance through the DC voltage source. Let us take VCC, and input is passing through. Means whenever if you want to pass a AC signal, so we are adding this a capacitance. So then we are applying the input signal here. And similarly, outputs are also, we are using that a capacitance. And across this one, we are placing the load resistance RL, which should be connected to ground potential. Across this, we are going to measure the output voltage. So let us take here, we have the two types of the current means. So whenever, so here this bypass capacitor means either the functionality of the capacitor based on the utilization of the capacitor, either it acts as a either bypass capacitor or a coupling capacitor. Means, so coupling capacitor means it is interlinked your given input signal to the terminal. Means whenever it is shorted, VA is directly passing through this base of the transistor. There, it is called as a coupling capacitor. But coming to this bypass capacitor, it shorts the AC signals to the ground, so that if any AC noise is there that present on a DC signal, then if it is removed, then it producing the cleaner and pulse pure DC signal. So that is the reason that AC noises will be taken into ground, then a pure DC signal will be produced at the output side. Now, similar to that, what is a coupling capacitor? So here, a coupling capacitor is used to couple or link means together from the AC signal from the one circuit element to the another. So hence, if you understand this is a stage amplifier, and for this amplifier, then we are going to pass this input signal through the capacitance. So here, let us take this is the AC signal along with the internal DC biasing signal. So hence, if you want to couple this AC source to and this amplifier, so we need to allow means we know that capacitor is allows AC sources and it blocks DC. Whenever the AC signal is passing through this network, the capacitor is acts as the short circuit. Hence, so based on this short circuit configuration, this capacitor, so based on that, this capacitor interconnects the your input node to the this means input source to one node to the another node. So that is the reason. A coupling capacitor is a capacitor which is used to couple or link together only the AC signal from one circuit element to the another. And we know that the capacitor is also another function is to block the DC signal from entering the second element and thus only passes the AC signal. Means capacitor allows only the AC signal. So whatever the DC source is there, that should be attenuated by the capacitor, and only the AC signal is connecting to one node to the another node in a devices. And define cutoff frequency. So coming to you, what is the meaning of cutoff frequency? So if you observe the filters concept, in a filters concept, let us assume that means it allows a lower frequencies. And suppose means the low pass filter. The low pass filter allows one of the lower frequency signals that should be within the limit of some given frequency. There we need to find out a cutoff frequency. So based on this cutoff frequency and up to from zero signal to up to this cutoff frequency, all the signals are passing through that low pass filter. So other than so means that beyond this cutoff frequencies, so that should be attenuated by the low pass filter. Similarly, if you are taking some high pass filter, so below this cutoff frequencies, the signals to be attenuated, and above this cutoff frequency, it should be passes to the side. So that is the reason. Here, the cutoff frequency is a half frequency and is a frequency where the power gain is off at a mid-band frequency, that is between the lower and upper cutoff frequencies where the frequency will be equal. And define current gain in BJT. So we need to define the current gain in BJT means bipolar junction transistor. So in this case, we are going to define the current gain. Generally, so gain means if any gain is defined as it is a ratio of output parameter to the input parameter. If you want to define a voltage gain, it is defined as output voltage to the input voltage. Similar to that, if you define current gain, then it is defined as output current to the input current. So that is the reason. The current gain of amplifier is defined as it is a ratio of output current to the input current. Means based on the transistor configuration. So we know that there are three types of the configurations are there. One is common base configuration, common emitter configuration, and common collector configuration. So based on that, so we need to define the gains of different configuration. So in that common base, the current gain is defined as alpha. In a common emitter, the current gain is defined as beta. Common collector should be represented as gamma. Or whatever it may be, it is defined as it is the ratio of output current to the input current. Now define what is common base amplifier. And we know that in a common base, so if you take the transistor or a BJT or a transistor, it contains the three terminals: emitter, base, and collector. So here we are going to define a common base amplifier. So base is a common, means if I consider the NPN transistor, let us take this is NPN transistor, and this is the base terminal, emitter terminal, and collector terminal. So base is common base, means base is a common for input side and output side. So here we are going to pass the input signal between emitter and the base, and output is a measure between collector and base terminal. And if you want to define the amplifier, we know that the input junction should be always forward bias, then output junction always need to maintain a reverse bias. Under this condition or under this active region, only the transistor is acts as a amplifier. So that is the reason. A single transistor BJT amplifier in which the input signal is applied to the emitter. So in this common base, the input is passing through emitter terminal. So that is the reason. Input signal is applied to emitter terminal, and here the output is taken from the collector terminal. And the base terminal is connected to a constant voltage, means that should be connected to constant. Either should be lower potential or a higher potential. It should be common for input side as well as the output side. Now, similar to that, define common collector amplifier. So hence, again, common collector means, so we have the three terminals, again emitter, base, and the collector. Now I'm going to take collector is a common. So let us consider. So I rotated this one. So this is I considered NPN transistor and emitter. This is collector. So at this point, so the collector terminal is a common for input side and output side. Means the base terminal acts as a input, and output is measured across the emitter terminal. Means that is with respect to emitter and the collector. Input is passing through with respect to base and collector. So that is the reason. A BJT amplifier in which the input signal is applied to the base terminal and output is taken from the emitter terminal, and the collector terminal is connected to a constant voltage. From that, and again, you should remember that always your input junction should be in a forward bias mode, and output junction should be in a reverse bias mode. Then only the transistor is enters into active region. Then we can say that that particular transistor is acts as a amplifier. So then define common emitter amplifier. So in this, so again we are going to take emitter should be common for input side and output side. So hence, let us take this is emitter, base, and collector. So common emitter means emitter is a common for input side and output side. We are passing the input signal, and here the output is measured between collector and the emitter. Then input is passing through base as well as the emitter, through the base and emitter. Output is taken from the collector to emitter. Hence, so in this, in which the input signal is applied to the base terminal, and in upper common emitter amplifier, output is taken from the collector terminal, and emitter terminal is connected to a constant voltage. So means emitter is making as a common terminal. So here we went up with a constant voltage. Now define biasing. So actually, why the biasing is required? So what is the meaning of biasing? Means if in a case of semiconductor diode, if you want to identify the behavior of the particular metal or material, then we need to apply some external force. So hence the way of approaching the external force to a normal PN junction, that it is called as biasing. So similarly, in a transistor case also, we need to identify a proper operating point, a quotient point. Then we need to apply an external force between the input terminals and output terminals. So hence, the technique of applying a DC voltage to a transistor or an active network. So what is active network? Means it contains any active devices like transistor or diodes to establish or to identify the proper operating point or a quotient point, that is also called as a Q point here. So hence, to determine this proper operating point, we need to apply a DC voltage source to the input side as well as the output side for this transistor. So that way of approaching the DC voltage to a transistor is called as the biasing. Now, what is thermal runaway? So here, due to the temperature, so the transistor means, let us consider, we know that for every 10 degrees centigrade, for every 10 degrees centigrade, the reverse saturation current becomes, suppose if you are in the diode current equation, we know that I is equal to I naught into E over V by eta times of Vt minus 1. So this is for a diode current expression. In this, where I naught is reverse saturation current and eta is a constant for that is for either germanium or silicon, and then Vt is a thermal voltage. So means for every 10 degrees centigrade, this reverse saturation current becomes double. Means if this reverse saturation current, or in the case of transistor, we know that IC is equal to beta times of IB plus 1 plus beta times of IC naught. So here also this IC naught indicates that reverse saturation current. So hence, for temperature is rises, then the reverse saturation current is also changes. If reverse saturation current is increasing in transistor, it automatically changes the collector current. So that is the reason. Due to this, it unstabilizes the Q point, means the Q point will be changes. So that is the reason. The self-destruction of unbiased, unstabilized transistor is known as thermal runaway. Now coming to your why is C configuration is most popular in amplifier circuit. So the reason is if you observe the common base, we have the three configurations: common base, common emitter, and a common collector. In a common base, the current gain is defined as alpha. In a common emitter, it is defined as a beta. Common collector is defined as gamma. So, as per the analysis of these three configurations, alpha is always lies between 0.95 to 0.99, and beta is always greater than 1. Greater than 1. In practically, the beta value is chosen from 50 to 500 values. So, in a common collector, gamma is means actually this common collector is acts as a voltage follows a buffer amplifier. It is actually a buffer amplifier. So a source follower circuit or a collector follower circuit. So that is the reason. Out of these three configurations, to improve the signal strength, so then we need to choose this common emitter configuration. So that is the reason. The physical quantities, like the physical quantities, are measured in terms of current, voltage, and power. So it should be quite high, and the ratio of the output impedance and impedance. So it should be some moderate condition compared with the common base and the common collector configurations. Hence, most of the cases while designing the C amplifier, we are preferring only the common emitter configuration. No, define base bias with collector feedback. So in this means that we need to make some biasing. In this, a biasing circuit in which the base resistor is connected between base and the collector to act as a feedback resistor. So hence, let us take. So this is a common emitter configuration. Emitter should be connected ground, and let us assume that this is biased with a VCC and a collector resistance. Then a base resistance is biased from the collector to base. So it is taken as the RB. So this is base terminal, collector and emitter. So at this point, if you observe this configuration, a base resistor is connected between collector and the base to act as a feedback resistor. This type of the approaching is called as base bias with collector feedback. Define base bias with emitter feedback. So base bias with emitter feedback means, so in this the its emitter resistance is connected to control the base current. So if you want to draw this one, let us consider a transistor in the previous case, and let us consider this is a collector resistance, and then this is biased with the VCC. Similarly, if a normal fixed bias method, so let us take this is RB, and this is called as a fixed bias method. Suppose if you want to control this gain of the transistor, then so here so means emitter should be replaced from the ground potential, and a biasing resistance is added across the emitter. That resistance is called as emitter resistance, and this type of the approaching is called as a base bias with a emitter feedback. So means to observe this potential difference means it is represented as VBE, means that VBE is also represented as the potential difference between base voltage and emitter voltage. So here what happens if this voltage drop with the changes, that is controls the gain of the operation or to controls the collector current. Then define self bias or a voltage divided bias. So in this case means to stabilize the Q point irrespective of your temperature conditions, then we need to stabilize the collector current. So with the variations means irrespective of the variations of temperature or current gain or the input voltage parameter, then we need to maintain. If you observe this one, the standard equation, IC is equal to beta times of IB plus 1 plus beta times of IC naught. Based on this expression, if IC naught is a changes, IC is also changes. If IB is a changes, that IC is also changes. If beta is a changes, again IC is also changes. Means IB means if VN is changes, IB is a change. So irrespective of these parameters, we need to stabilize the collector current. Then only the Q point becomes stable. So if the Q point is becomes stable, then only we can use as a amplifier conditions here. To stabilize this one, most of the cases we are going to prefer this cell bias. Means automatically internally the circuit stabilizer. How much factor of the collector changes, that should be controlled by the internal circuit operations. So hence, so to control that one, the input side, we are using the voltage divider network. So the base is connecting through this voltage divider network, and let's say this is R1 and R2, and this R1 is connected with the biasing voltage source VCC, and should be connected to ground potential. Output is taken from the collector, and this type of the biasing approach is called as self bias or a voltage divider bias. Now define stability factor. Yes. So here we have the three different stability factors. So S, S dash, and S double dash. So first we are going to identify that S means. So just now we discussed that the collector current is represented as IC is equal to beta times of IB plus 1 plus beta times of IC naught. Means the rate of change of collector current changes with respect to the rate of change of reverse saturation current, or the rate of change of collector current with rate of change of your input parameter, that is VBE parameter, input voltage, while I'm considering the common emitter configuration, or the rate of change of collector current with the changes with respect to the variation of the current decay. So in these cases, how the collector current is changes with respect to change in parameter of reverse saturation current or VBE parameter, or like this current gain parameter. So here we are identifying the stability factors. So in this, the rate of change of collector current with respect to the reverse saturation, means this one. The rate of change means S is the defined as the rate of change of collector current with respect to the rate of change of reverse saturation current. At this point, by keeping the current gain, emitter current gain, and mains current gain means beta, and the base current as a constant, means we need to make that VB is a constant, then base current becomes your constant. So that is the reason. So we need to take VB and the beta is a constant parameter. These are the three parameters affects the change in collector current. If the collector current is changes, output voltage is also changes. If these two are affected, the Q point is also affected. So hence we are identifying this as the stability factor in terms of these parameters. So like that, we need to define stability factor S dash. So here the S dash is defined as the rate of change of collector current, means S dash is defined as the rate of change of collector currents with respect to the base current, that is defined as dou IB. Now similarly, then define stability factor S double dash. So in this, the S double dash is defined as the rate of change of collector current with respect to the current gain. Means common current gain means that is beta, dou beta, by making that base current as well as means IC naught and VBE is constant. Now define compensation technique. So means if you want to in this collector current equation in the transistor, so if any one of the parameter is affected, means either IC naught or beta or your input current is affected, it also affects the collector current. To compensate how much collector current is changes with respect to the change in these parameters, so we need to use some methodologies. That methodologies here it is called as a compensation techniques. So that should be compensated. So all these parameters are with respect to temperature dependence parameters. Hence, so here we are going to use a temperature sensitive devices like the size diodes and thermistors, transistors, etc. to compensate that the change in collector current. So that is the reason. Instead of this DC bias circuit, we need to use these devices to stabilize the Q point is called as the compensation. Now define linear amplifier. So here a linear amplifier provides amplification signal without any distortion, so that the output signal is an exact amplified replica of the input signal. Means so most of the cases amplifier means without distorting any input signal, we need to generate the output signal. So at this point, V naught is approximately equal to your given input signal. That type of the amplification process is called as the linear amplifier process. Now define AC analysis. So in this case, so to identify the amplifying conditions here, so perfect means to identify the perfect Q point or operating point. So we need to identify the two load line analysis. One is DC load line analysis. Another one we need to do AC load line analysis. So in this case, to analyze the AC signal operation of the amplifier, then we need to convert it to with the equivalent AC circuit by short circuiting the DC sources as well as the capacitor. So means that why we are making short circuit the DC source and capacitor means the capacitor allows only the AC signal. Hence, whenever the AC signal is passing through this capacitor, it acts as your short circuit. Now, define attenuation. So what is the meaning of attenuation? Attenuation means to, let us take, this is your given input signal, and while transmitting this one, if signal loses any component, either maybe suppose I want to attenuate this positive portion of the given signal, I need to only transmit this negative portion, or I need to transmit only the sum of the positive portion. I need to skip this negative portion. So that is the case, then we are going to reduction of the signal voltage. So hence the attenuation is the reduction in a signal voltage as it passes through a circuit and corresponds to a gain of so less than, means here at this point the gain should be always less than 1. Now define load current. So means the load current means we need to take from the output of the amplifier here. So here the load current is the amount of current drawn from the output of an amplifier or other circuit through a load resistance. Suppose if I take this is the amplifier circuit, then across the output side we measuring some load resistance. So across this load resistance we are going to measure the output voltage, means how much current is the flows across this load resistance, and that should be defined as here the load current. Now define stability. The stability is a measure how well an amp means. So why this stability is required actually? So means once the Q point mean, let us take suppose in a transistor characteristics, we are taking output characteristics. Output characteristics drawn between VCE versus IC, and at this point, so we need to draw the a DC load line. So this is called as a DC load line. Then again we need to draw the AC load line here. Then first we need to define the Q point. The Q point is always center of the DC load line. Then so we take and this is AC load line. So means once the Q point is fixed, then we need to maintain a stabilization. So and stability is the measure how will an amplifier maintains its design values over changes in temperature or for a transistor with a different beat. Now define power gain. The overall power gain is generally the power is represented as the product of voltage and current. So hence the power gain so is represented as AP, that is represented as the product of voltage gain and with respect to the current gain. So hence the overall power gain is the product of overall voltage gain and overall current gain AI. Now define decibel. So most of the cases in amplifier, that frequency we are measuring in terms of decibel means the gain factor we are measuring in terms of decibels. So hence a logarithmic measure of the ratio of one voltage to another or one power to the another. So that is nothing but your decibel. Now define AC ground. So what is the AC ground? What is the difference between the DC ground? So in this, a point in a circuit that appears as a ground to AC signals only. So means let us take this is the AC signal, and here this is called as AC ground. Now define voltage amplifier. So in this, so generally amplifiers means so it improves the signal strength of a given input signal. So in this case, the amplifier circuit that increases the voltage level of the input signal is called as the voltage amplifier. Means we are writing this one, V naught is equal to A times of V. So this is the factor. By amount of this factor, that input signal voltage should be increases. So that is called as here the voltage amplifiers. Now define power amplifiers. The amplifiers are circuit that increases the power level of the input signal is called as the power amplifier. So means already just we discussed the gain of the power. So AP is defined as the overall voltage gain is a product with the overall current gain. So that is the reason it increases the power level of the input signal here. Then the type of amplifiers is belongs to power amplifiers. Now define small signal amplifiers. So when the input signal is so weak as to produce a small fluctuations in the collector current compared to its quiescent value. So then this type of amplifier is known as small signal amplifier. So the small signal analysis, so that means the amplifiers is analyzed with a very low frequencies or low voltage signals here. So that is the reason when the input signal is so weak to produce a small fluctuations in the collector current. So compared to its quotient value means a Q point, then the amplifier is known as a small signal amplifier. So what is the purpose of the DC biasing circuit? So actually the DC biasing circuit is to identify the proper operating point as well as the proper operating region. So if you consider the PN agenda here to identify the behavior of that one, we need to apply or we need to apply some amount of the DC voltage source to that PN junction. Then we need to identify how much DC voltage is required to state to make the conduction of that particular device. Means to change the state from off state to on state. How much energy is required to change the state from off state to on state. So that can be done through this one, the DC biasing circuit, to turn the device on and to place it in operation in the region of its characteristic where the device operates most linearly. To set up the initial DC values of means by setting this one base current and the collector current as well as the VC. Why? Because of the Q point is a functioning of collector current and output voltage. So in this case, now we need to maintain a proper operating point. So in this case, to maintain this proper operating point, we require a proper biasing circuit that is done through a DC biasing circuit. Again, so if you observe this IC, then we know the generalized deflation IC is equal to beta times of 1 plus beta times of IC. So hence IC is again directly proportional to your input current. So that is the reason. We need to maintain a proper currents and the voltages to make the proper operating point that can be done through your DC biasing circuit. Define frequency response of an amplifier. So by frequency response means we need to plot the graph between it is a measure of magnitude and the phase of output as a function of the frequency in comparison to the input. So means we need to identify that means we are drawing the graphical representation or by using that frequency response we are measuring that magnitude means as well as the phase of the means in a CE amplifier we know that V0 is equal to minus VA. So you define this is 180 degrees phase shift with respect to the given input signal. So from that frequency response we can identify the maximum gain as well as the phase of the given output with respect to your input signal. Now define bandwidth. So generally the bandwidth is defined as the potential difference between upper cutoff frequency and lower cutoff frequency means FH minus FL, or you can write the potential means the difference between the two frequencies F2 minus F1, that is also called as bandwidth here. Now define DC analyze. So to identify this again a DC load line. Now first we need to identify the DC equivalent circuit. So to identify this DC equivalent circuit, first we need to replace that AC voltage sources to ground, and again we need to make the capacitors open circuit. And if any circuit conduct and the inductors, that inductor should be replaced with a short circuit. Then find out the proper Q point from the given equivalent circuit. Means if any network contains a passive components like a resistor, inductor, and a capacitor, along with the AC and DC sources, then for this case, if you want to identify the DC equivalent circuit, so that inductor should be replaced with a short circuit, and the capacitor is replaced with an open circuit, and all the AC sources will be we need to remove. Then we need to find out the equivalent DC biasing circuit, and from that AC equivalent DC biasing circuit, we need to find out the proper operating point to identify a particular operation, means transistor amplifier operation, by using this DC analysis. You define inverting amplifier. So generally the inverting amplifier means that is the inversion of the given input signal. Means the phase shift should be opposite here. So this inverting voltage amplifier circuit which produces an output signal which is an inversion of input like common term. So why? Because we know that in a CE amplifier the output voltage is 180 degrees phase shift with respect to the input signal. So that is the reason the V naught is represented as minus V. At this point, this is called as the inverting amplifier. Now define a current follower. A current follower is a circuit designed to copy a current through one active device by controlling the current in another active device of a circuit. For this case, so we need to keep the output current is a constant regardless of the loading, like common base or a common gate. Means common gate, this is case is of 8 amplifiers. So the common base means in the case of BJT amplifiers. Now define voltage follower. A voltage follower is also called as a unity gain follower. So means if you observe the common collector configuration. So in a common collector configuration, the output is taken from the color emitter terminal. So in based on the transistor construction, we know that emitters always inject the charge carriers. Then output is also measured across the emitter ends. Most of the case, how many charge carriers are emitter, and that should be useful for to make the conduction device. So here, for this common collector configuration, the output is again measured across the emitter. So that is the reason. If 90% of the charge carriers are emitted, then we are measuring this 90% of the charge carriers. If 100% of the charge carriers are emitted from the emitter, and that should be measured across again the emitter ends, we will respond the 100%. So then, if you observe this voltage gain for this case, so we have the unity gain. So this unity gain is called as a voltage follower circuit, or it is also called as a buffer circuit. So that is the reason. A voltage follower is also called as a unity gain amplifier or a buffer amplifier, and is an isolation amplifier circuit which has a voltage gain of 1, like common collector. And similarly in a FET case, so that is also a common drain amplifier. Their common drain amplifier is also acts as a voltage follower circuits. Now define stabilization technique. So means what are the techniques are required to maintain a proper operating point with respect to the change in, means with respect to the thermal temperature, the changes some parameter like this IC naught, beta, and phi. So means that is the reason. It refers to the use of a resistive biasing circuit which allow the base current to vary so as to keep IC relatively constant. The variations of in IC naught means reverse saturation current, and this is the DC current gain of the common emitter configuration, and input voltage means if temperature changes, so these are the temperature dependent parameters, reverse saturation current, beta, and input voltage. Due to that, if any parameter is affected, it directly proportional affect the collector current. So means we need to maintain to provide the proper operating point. Again, we need to compensate this, or we need to stabilize the operating point. So how we are going to stabilize this operating point by using the biasing circuits or a resistive bias circuit. So that can be allowed to, we are going to maintain, or to relatively we are maintaining a constant collector current with irrespective variations of either reverse saturation current or beta and VPE parameter. Now, what is the stability factor? So, means it is defined as the degree of change in operating point due to the variation in temperature. So, that is called as a stability factor. So, up to this point in this session, we discussed the definition terminology in module 3. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.